recording? Good. Well, welcome everybody to our panel tonight. We are the local user group. Myself represents the local user group, the Northwest C++ Users Group. And we work with John and the conference to help show other communities how to utilize events such as this to their benefit and to get speakers and deal with some issues that we all have in our work. And tonight we're doing a panel about being embedded in C++. And so I'm thankful for all of you showing up. My name is Brett Searles. I'm the Vice President of the Northwest C++ Users Group. I also work for my own company called Adobotics, where we work on holographic surgical center, and it involves a lot of embedded because we have to work with image capture and holographic graphics and how to interact with data. And so now I'll hand it over to Dan.
For what purpose?
To introduce yourself.
Oh, okay. Hi, I'm Dan Sachs, and I make a living providing training, and my particular area of interest is the use of C and C++ in embedded systems. And in particular, what I think are the interesting problems are problems of using the data structures and facilities of a language like C++ to be able to model hardware resources, something that remains a very interesting challenge. And somehow or another, I guess, some people think I know something about this topic.
Hi, I'm Odin. I think he knows something about this topic. I spent most of my career programming microcontrollers in assembler, and at some point had shot myself in the foot more than one too many times, and I didn't really see the advantage of C, because you can shoot yourself in the foot almost the same number of ways, and I lament the fact that there isn't a whole bunch of C++ infrastructure that actually stops you from doing that, because we do have the language features to do it. And so I wanted to go to a conference where you learn how to do that, and there wasn't one, so we founded one. So yeah, we run the EMBO conference in Germany and are trying to completely rethink how we do at least the lower end, the bare metal, the microcontroller end of programming.
Hi, I'm Ben Sachs. I'm the chief engineer with Sachs & Associates, so I work with Dan doing most of our modern course development, trying to look into ways of taking advantage of the latest and greatest C++ features from the more recent standards and applying those to embedded development. Before doing that, I spent about 12 years working on a small embedded system that functioned as a production line monitor, something you'd hook up to a production line and allow it to gather statistics about various ways in which you could improve your performance in that area. So that's my basic background here, and I'm hoping that Odin has just said so much of what I like to think of as the really important benefits of C++ that I'm hoping I'll still have things left over to say.
Hi, I'm Andrew Sloss. I work for ARM Research, and I'm based locally here. And I've come from an embedded background. I teach embedded systems at the University of Washington part-time. But my sort of day job is actually looking into the future. So my job is to look at disruptive technology roadmaps. So one of my parts of what I look at is what happens to programming languages in the future, what is likely to occur as we sort of shift from what I would call an exploitive world to an exploratory world. So if you look at all the press and everything, you'll see all these machine learning type concepts coming up, and actually that's going to have quite a big effect on what we do as embedded programmers as well. So that's the world I live in. It's slightly different to the details of C++, but I'm very deeply connected to the embedded world and how that's going to affect that world. So.
And as Odin was saying, he's very interested in the structure and how to implement it in C++. And that is one of the things that the study group SG14 is doing. So if any of you want to join that group to help push things into the standards, we ask that you join us. And we have conference calls once a month, and tomorrow actually we have a whole day event at the Courtyard Marriott. Unfortunately, you have to have a sticker, so if you haven't gotten it, just we should have some notes from that coming up. So if you're interested, let me know.
But yeah, we're on SG14. We're happy to have you along. If you look at the attendance numbers for most of the study groups at the conference, most of them say 10, 15, whatever. The way that it's been written for SG14 for the last few is just lots. So don't feel like we have a cap or anything. We can accommodate you.
And the main focus is low latency, which is definitely an issue for the embedded world. And so that's one of the subgroups inside. So we have microphones on both sides of the room, or the aisles here. So if any of you have any questions, we would like you to step up to the microphone. So this panel is not just us here sitting and telling you what our experiences are, but it's also for you to ask questions. So if you have any questions, go ahead.
Well, let's state views, not just questions, views as well.
Views and, yes. Last year we had an entertaining panel, and so therefore I had to bring one of those individuals to the panel because we enjoyed his insights. So.
Well, now you're not going to get any questions.
Anyone want to be the first?
All right, fine. Okay, so a couple years ago, then you had the "if you're arguing, you're losing" type thing, and trying to convince people. Trying to convince people to start switching from C to C++. But once you get that convince people to do it, you've got all of this old code with macros and globals and link time compile flags. How do you go about starting to craft a code base that uses C++ with all of the legacy crap?
By the way, is that mic on?
I don't know,
It sounded like it was.
No, it didn't sound like
It didn't sound like it was on.
No, it didn't.
The question is, given that you have a legacy code base that's largely C, and you have persuaded people that it is worthwhile venturing into C++, see, that's the hard part.
Right,
The question is now, okay, what next?
Right.
Where do you start?
right, with all of the macros and
And
globals.
part of that is you can't throw out the legacy code base, right? You have to keep it alive, okay? My own advice in that regard is, first of all, you still have to observe the rule that if it ain't broke, you don't fix it. That you don't want to be in the position of going and diving into code that's functioning and has no issues, and just going in and changing it for the sake of changing it. There has to be a future direction, a need to go in it. But if it's a code base that has life, it means there are identified fixes that you need to do. And so when you identify that area to fix, then what you have to do is do an assessment of the impact. And what I tend to start with is there will almost typically be certain collections of resources. It could be a cluster of registers, or it could be something that is already packaged as a struct in the C code, where you say, okay, if I've got to go in there and make some changes, can I do some refactoring first In other words, I'm familiar with the discipline of refactoring, which is it's preparatory work you do before you go in and actually make the changes. And if you're really being rigorous about refactoring, you have various regression tests to make sure that the refactoring hasn't changed functionality. But what I like to refer to that is it's really you're mining for objects. You're looking for opportunities to take things which are poorly structured data and restructure it into classes before you try to make further changes on them. And what I usually find is that some things don't leap out right away as something that you've worked, but other things, hey, if there's already a struct there, and there may already be a collection of functions or macros which provide rudimentary operations on that data, I would say, do the assessment, can I refactor that into a class with proper access control? And look at, is there a natural way to package construction for that thing? Is there a need for some kind of cleanup, destruction? See if you can do that kind of stuff on that, and then use that as the basis for then doing further enhancements. And I find that there's usually some things that just leap out at you, and other things where you say, boy, I got to labor real hard, let's wait on that.
There's a different approach as well. And it's a case of, in embedded, you're quite often trying to learn what the code is supposed to do, right? So the reason for moving it into C++ or going the other way is a method of sort of trying to work out the logic of the original code. So a good, even if the code works and it's well known and all of these other things, that transferring it to C++ means you get a sort of deeper understanding of the actual original code. Because in embedded, you are responsible for the entire stack. Even if the code comes from somewhere else, you are in the end the responsible party. And especially in safety critical stuff and all of that, you definitely have to understand what that code's trying to do. So as an exercise, transferring it to a language or another language is a good thing. So.
But I'm a little puzzled. You said there is another way. I didn't hear that there was anything that you said that was in conflict with.
No, not in conflict, but as a learning exercise. You said, keep the original code and keep it the way it is, absolutely. But as a learning exercise, as you're responsible for all the code base, maybe you have to transfer it, right? You have to move it into another world, or you have to rewrite it into a style that you understand, right? Because in the end, you are responsible for that code base, right?
But were you suggesting go up and first do just some practice exercises before you dive in?
Yes. I mean, I've got a good examples where I've looked at code and then did the transfer, and I go, well, this line is meaningless, right? In embedded, it has no value. Why is it just randomly poking into DRAM for no apparent reason, right? And that was a crucial line that actually initializes the whole DRAM controller, right? And and then when you run the code, you're going, well, why is all the DRAM all corrupted? And it's all because I didn't run this weird line that has no value or appears to have no value, right? So it's a way of understanding the hardware, and the hardware always has odd tweaks that just don't make any sense to software people. Why on earth do you have to do this random poke into DRAM to actually get the DRAM controller to work? So that's why it's good to transfer to another one.
And I just want to reinforce the one point you said was access control. If you can make a branch off of the main branch and do your own experimentation, then you can find out ways to improve performance and memory analysis.
Another thing that I will add, it's easy to come from an environment like this where we're talking about a lot of cutting edge C++ features and think about, oh, okay, I want to go turn my code into, make full use of variadic templates and all sorts of the most impressive C++ features. But when you're just doing an initial step from plain vanilla C into C++, you don't feel like you need to necessarily go to that degree. Once you get it compiling as C++. Most C will compile as C++, but there are a few cases where C++ has more strict type safety requirements. But as soon as you get it compiling as C++, you have a C++ program there. And then you're free to start making incremental improvements to gradually work your way towards some of those more advanced techniques. But if you have some people in your organization who, your original question had it that I've got people convinced to move to C++, but I can imagine that in many cases it may be a sort of tentative thing where some of them are saying, I'll give it a shot, and then as soon as they see something that confuses them, they might say, whoa, scary. So you can take it one step at a time. You want to make incremental improvements that fit with where your organization is as a whole, and don't force people too far out of their comfort zone. Some stretching is good, but you go too far and you'll pull a muscle effectively.
Yeah, I'd definitely agree with Dan that it's touching legacy code where maybe the person that wrote it doesn't even work for you anymore, or you have these kinds of problems is the other thing. If it's legacy style C, it probably doesn't have a lot of unit tests, right? Sure. And if it's bare metal or touching metal, it probably doesn't have a lot of unit tests, because that's really hard to do in C, especially touching hardware. The one area where you can write unit tests the easiest is probably where all the macros are, right? So, I mean, if you can migrate macros into consexpr, you can write unit tests for the old and new at the same time. And that's probably an area where you're going to hit the least number of landmines and maybe get, continue to inspire people to migrate to C++. I mean, if you're going from legacy C to C++, you're probably also changing compiler in some way, shape, or form, which means that, volatile semantics might be changing slightly, right? I mean, this is if you're going from, say some old IAR compiler version to GCC, you're probably finding a few volatile bugs there too.
I was wondering, for a person who might be in more high-level software stuff and is thinking about descending down in, could you guys speak to like what's easy, hard, and impossible in embedded right now, and what direction we're moving from that?
I want to make sure I understand the question. You're talking about yourself? Are you someone who works at higher levels of application domains, and you're wondering how do I get
if I was
fingers, my hands dirty?
Yeah, if I was interested in getting my hands dirty, and what kind of things should I rule out?
Now, is this something because you're hoping to change jobs?
Right.
You won't tell your employer. It's that, as opposed to this is on-the-job training. You want to just do this off, like for your own edification and a possible career change. Is that the nature of the question?
Or embedded types, right? You've got Arduino on one side, right? If you want to play with Arduino, or you've got Raspberry Pi, or you've got some other microcontroller.
Yeah, something like that, where you're used to working with something theoretically small like that, but you're thinking about going even smaller, or something that has fewer or more limitations.
Arduino is, a really good way to go, right? So if you're going to learn sort of embedded in a sort of protected environment with lots of documentation, with lots of sort of nice boards that people have played with and stabilized and all of that, then it's a great tool. The one where you get to, what brings every embedded engineer to the same level is a completely bare board that has never had any software written for it, right? So even the best embedded engineers start at the beginning when they get a bare board with no software whatsoever. So there's a big difference between the software which has already been prepared and the software that it doesn't exist. right? And so for the bare bones one, all embedded engineers, have suffered the same pains. They have to go through the memory maps, they have to work out how to get some basic serial working or some way of communication, and then you work up the scale. And so, if you want to go there, then that's the hardest bit, really, is dealing with a board. And even harder than that is dealing with a brand new chip that has never been brought up. So you talk about extreme hardness is a chip that you don't know even works. And so you're starting to prod different parts of it to find out whether there's any life in that chip at all. And so you've got many different levels, right? So, so chip that doesn't work or not known to work, a board that is not known to work, a board with some software support, Arduino, then you've got Raspberry Pi, and then you've got other things. So there's many levels, and so it's...
Okay.
Well, and so what were you aspiring to do is the question. He just told you what your choices were. Which one of those sounds appealing?
Well, to be honest, I don't really know. I'm used to more something like Raspberry Pi, and I was wondering what it would take to go down. How would I be limited to start going smaller? Are there certain like language paradigms or something that are off limits or unexplored or something that?
Well, I'm not sure I'm going to answer your question, but I'm going to take a stab at it, which is when I started doing this, basically I had a knowledge of C and C++, and the first board that I acquired, it was actually a board that Andrew gave me, and it came with a package of a demo compiler from ARM, and it was loaded with a bunch of programming examples, all of which were written in C. And they did things like blink lights and responded to push buttons. And I just took a bunch of them and said, based on what I know about the C++ language, let's try rewriting these C programs into C++. And I did it very incrementally like that, just a very experimental approach. And now you can find, 15 years later, occasionally people have produced books on this, although the problem, for example, I'm thinking Michael Barr wrote a book on embedded programming with C and C++, where he did something like that with a particular board. I don't know if that board's available anymore. You may be able to go out on eBay, but you can get a book like that and follow the examples. And that's programming at the bare metal level. And in fact, Ben and I are going to be doing a course this weekend here, where we're still using that board. It's an ARM7 board that we got from Andrew, that we do exactly that. We start with a C program and show people how to gradually migrate it into C++ code by making incremental changes on the data representation and the executable code that follows. And it just blinks lights and responds to push buttons.
But I mean, the one interesting challenge is you can spend a lot of time getting a blinking light working, right? And no one else will appreciate it, apart from other embedded people, right? So you'll spend hours upon hours, and then the excitement of getting a blinking light working is quite exciting, but as I said, not for other people. So
Depends on also what application you want to apply it. What do you have a?
No, I just was curious if there's like a broad answer that you guys usually have or something like that. You guys have answered it pretty well, so I'll step aside.
Well, an interesting thing about what you're talking about there is that in a lot of respects, embedded programming is not that different from ordinary programming. A lot of the code that you would write on an embedded platform is not that much different. It's not the safety critical stuff. It's not the high performance stuff, because there's a lot of infrastructure that you need. And so you might, if you were to dive into embedded programming, you might find that for the first several pieces, oh yeah, I know this, I know this, I know this, and then at one point you'd get to a thing where you say, why is that not working? And then you have to dig into it, and you have to see, oh, because I need a volatile here where I wouldn't have needed one in another situation, or various things like that. So that's one path that's sort of the path that I took, where when I started developing for embedded, I was coming out of college, and I knew C++ as they taught it to me there. They didn't really talk that much about the embedded space, and then just over the course of working on it, I gradually learned oh, okay, in these situations, I need to do something, now I'm dealing with something that is very timing dependent, so now I need to be much more careful about what code I throw in there and things like that.
Okay, next.
Hi, this is a two-part question. Maybe I'll start with a little bit of context. So my team works on computer vision, embedded platform. We do everything in C++, hopefully C++ 17 soon. We actually use a lot of the features to prevent us from shooting things, like mostly through the battles we learned some of those. We have a sister team that works on the more lower level aspects of the system. So it's kind of like a follow-up on the, or maybe a pre-follow-up on that question, where if they write everything in C, right? It's actually not that bad. Our life would be just slightly better if their libraries would be in C++. And so that's a two-part question, right? Like, what would it take to convince them, right, to the C++? And second, is that even worth it? Because when I look at their work, they actually write pretty good C. If I would, like, I've never seen a C-based code base that is actually very well structured, and they do pretty well. So.
Do they use a lot of types, or struct types, or?
Yeah, and I could look at their code base and see, oh, all these limitations that, because they don't have C++, but they have their own ways of making things structured in a logical way. But
Yeah, sure. I think, you know, as you get closer to the metal, and especially as you get more resource constrained as far as RAM, the time domain plays a much larger role than it does on larger systems, right? If you're, writing something on a Google server farm, you want amortized speed. I don't care if it's pretty slow one time, if it's fast the next 1,000 times, we're great, right? But as soon as other people send you stuff, and you have a limited number of RAM, or a limited amount of RAM, you are essentially a hard real-time system, because either you have a hard real-time constraint on telling them to stop, or you overflow, or you deal with it in time, right? And we aren't really used to, as a larger C++ community, thinking about strong encapsulation, including the time domain, right? We think about encapsulating things and local reasoning in terms of functional correctness, but not necessarily in terms of time, right? We had this discussion recently in the SG14 that we don't even know what semantics to use to talk about the determinism of standard library functionality, right? So, yeah, I mean, I think this is, me onboarding people into my company. Some of them are coming from a C++ background, and the thing they stumble over the most is, so I can't just run and then when I'm done I deal with that thing, because that might be way too late. So I have interrupt service routines, I have different kinds of preemption. In my interrupt service routine, I can't take a lock, because that's just not part of the paradigm. I'm on that thing's stack, so I can't, if it's already locked, cycle back to that other thing. And it leads to a different style of programming eventually.
Well, I want to go back to the problem analysis, which is, I guess, correct me if I'm wrong, but it sounded to me like you want to persuade them to rewrite their pretty good C.
no, so they already write pretty good C.
Yeah.
That's at least in my view. But if I have like a magic button,
Yes.
hey, now you guys are all C++, I would press the button.
You would press that button.
But
Unfortunately, that button doesn't exist.
the button doesn't exist. The good thing is, like, we're working on a new generation So they're actually going to start most of the
Are they writing a new
programming.
code base now?
Yeah, but they're all C programmers.
They're all C programmers. The problem is that it sounds like in the current situation, it's only kind of like my life would be a little easier if that were C++.
Yeah, for me it's very marginal.
Right. Yeah, I'm not sold either. In other words,
Okay.
a major lesson in life is learning to pick and choose your battles, right? This doesn't sound like there's a big payoff from the cost it's going to, the toll it's going to take on you and your relationship with these people to get them to do what you'd like them to do. I mean, but I would say if you do want to make that effort, I think the burden would fall on you to try prototyping, taking a small snippet of what they're already delivering you, write it as the best C++ you can, and show them that there is either and or a gain in the robustness of the interface, that you can turn what would have been runtime errors into compile time errors.
Yeah,
And say that's a quantitative. The other one is show them that it's faster and more compact. If you use, for example, const expert very effectively, you may be able to obtain those gains and make that case before they get into that.
I think the marginal benefit that we would get will not be on the table. It's more like what they can get. Like, let's say
What they could get?
if you go from a really good C style to a really good C++.
So is this sort of firmware and application? Is it that's all the code that's running on here, or is the C world more of a kernel and you're just one of the applications? I mean, what's the environment? Is it?
We are pretty much the only user. So
You're a single user
yeah,
with that.
Yeah. So they do all the library, drivers, scheduling, and so forth. But we just write the computer vision algorithms.
Well, this is your opportunity to teach. So why don't you say, hey, at lunch or after lunch, hey, I just wanted to show you some cool things that I've learned in C++. Just for, your knowledge edification, And maybe they'll say, oh yeah, I could use that instead to give you better interfaces.
And you can do it gently. They don't have to jump straight into the whole world, right? I mean, they can do it as a really gentle, this is a really good technique. You can use that. You don't have to go straight to the whole thing.
Just make sure you buy something for them, get some goodies.
Some cookies and cakes.
All right, next. Oh, are you done? Great.
If I could just kind of add to that, one thing that helped me is I noticed that a lot of the C code they wrote, they used a lot of conventions to have like public and private and stuff like that, like separating things out just by convention. But then a lot of the private stuff would bleed into the public because it was easier that way. So you can kind of convince them that, well, C++ you can write almost the same code, but that public and private will be enforced by the compiler, not just the conventions. So, but I did have a question too. So when going to C++, one of the things that seems to be lacking in the embedded space is the tooling. It seems like a lot of the vendors and a lot of the tools not only don't support modern C++, but some of them are still lacking in like C99 and C11 support. So how do you deal with that, I guess?
I'll let Andrew answer that question since he works for ARM.
Actually, I don't work for the tools group, but I will say from an embedded point of view, it depends what embedded we're dealing with, right? So embedded has a set of rules, no clever coding, very, very strict to the hardware. There's a whole lot of things like no dynamic memory, no anything. So on the strict embedded side of the world, you start chopping bits of C++ out because of just dealing with traditional embedded systems. So even though you've got all these clever things, you can't call dynamic memory in any of them, right? So when you come down to embedded C++ compilers, you will see them being very, very conservative because of what they have to deal with. And if you deal with the automotive industry, you got Mr. C and Mr. C++ and all of these, where you keep to a very strict subset of the language, not the full language. So that's why you're seeing that. And in the application world, you're fine. You can go all over the place. You've got malloc and free and new and whatever, and you can do all of that stuff. But for embedded, you have to go to the most conservative if it's the sort of safety critical side of the world. So.
What I'm inferring from what you're saying, your experience is a lot like mine, which is that the tools for embedded development tend to lag behind the tools for desktop development by anywhere from 5 to 10 years in terms of the introduction of features. And some of that is that although the compiler front ends may support certain stuff, it's the required additional support of the back-end tools. The linker and the debugger and the profiler and all that kind of stuff is apparently more of a challenge, and so the vendors just deliver that less rapidly. But nonetheless, there are still a core set of features of C++ that I think you can reliably assume will be in every compiler that you use. I think it's pretty hard to find a compiler that doesn't have classes, access control, constructors and destructors and static members and things like that. Where you're going to have the problems is, does it support user-defined literals and all aspects of type traits, things like that. That's where the lag is going to be. But that's not where you start, right? You're going to start as you migrate from C to C++. I'd say the biggest bang for the buck is simply using classes and access control and member functions in appropriate fashion. And I really don't think you're going to run into a problem there with respect to language support.
What about other tools like, step debuggers or IDEs or like a lot of the other tools that you see with a lot of the desktop C++ type development?
Mm-hmm.
Like it seems a lot of those are lagging way behind as well. Like is there any effort, like overall, just in the embedded community to start making better tools?
That's really interesting, because I had the impression instead that a lot of the tool vendors for embedded products don't compete on their language support, they compete on their back-end tool support. It's like if you wander the exhibit floor at something like the Embedded Systems Conference, the tool vendors will rarely tell you, look at all the language features they'll support. They show, look at the richness of the debugging capabilities. That's what they're trying to compete on.
And different tools vendors aim for different parts of the market. Some aim for simplicity, and some aim to expose all the horrible parts of the processor, right? So you've got very different levels of tools. Absolutely, to Dan's point, there are so many different variations, and it depends what market they're aiming at. You can get tools which give you too much information. Actually, it gives you sort of too much to try and filter.
Right. So if you're already using a particular tool chain that doesn't have that support, what I would say is just shop the market. You may find that a different vendor has got that stuff in their back-end tool set.
And quite often linked to JTAG debuggers and all of those the hardware side and traces and all of that.
What we use at work is just GCC with GDB and CMake and either the JetBrains CLine IDE or Seger Ozo debugger. And this is not something that ships from any vendor, but as long as it's an ARM Cortex or whatever. And I guess I'm going to disagree with Dan a little bit. I'm not really impressed with the debugging capability of a lot of these things, because they're helping me find bugs, sure, but I'd rather find those at compile time. A lot of them you can't if you use sort of modern static checking kind of interfaces, and I think a lot of the tool vendors just don't get it, right? I mean, a lot of those bugs, I want to find those in unit tests. If I'm using some vendor's out-of-the-box IDE and compiler, that's very hard to do, right? It's especially hard to do in C in sort of the style of the drivers they give you at zero cost, right? I mean, you really gotta, I mean, or to your point, they don't want to support clever coding or cryptic complex coding unless it's macros, of course, right? So,
Well,
there's
the hidden magic that locks you into their tool chain. I mean, if you want all of that, I mean, we can go back to Ada as well, right? And for those who've had the Ada experience, it was quite interesting. Because once you compiled an Ada program, you were sort of like 90% sure it would run and it would execute. Right? Whereas in C and C++ or any of these other languages, in some ways you're hoping that it would execute. There's a different view, but C and C++ gives you so much more flexibility. So it's a compromise on the language side.
Okay, go ahead.
All right, thank you. So I have a question for you, but just to make you understand the question, some context first. So we have a code base, and our customers come to us with different chipsets, and they want us to compile this code base for them. And that means we run into a lot of weird compilers, and we have a small subset. Currently, we are not writing code in C, we're writing code in 98. So from all the compilers we've been thrown at so far, the last one has finally gotten some kind of C++ 11 support. From what you're seeing, from where you're sitting right now, do you see it to be safe to go to C++ 11? Or do you think, in this general selection of compilers, is that... Do you understand the question?
Well, I think it depends to some degree on what kind of chips you're being presented with.
Like some examples are Tensilica, ARM,
Different compilers.
I will tell you Ben and I have an experience. We have a customer base that they hire us to do C++ training. And up until this year, we had always structured our training materials so that we were covering all of what were the core features of C++ 9803 and putting the modern C++ stuff at the end because not everybody had tool chains that could handle those things. And we would tell you, okay, this way we can get through everything, and then if you don't have tools which can compile this stuff, you'll just have to read along and follow, and won't be able to actually do the exercises. And this year, the last of our clients said, go ahead and integrate C++ 11 throughout the course. We have given up on our mandate to stick to C++ 03. But that's just our experience. So we now feel that it's safe to weave C++ 11 features through our entire code base. Now, we're still not weaving C++ 14 and 17 stuff necessarily, but we're starting to use a generous assortment of C++ 11 features.
Could I just ask the audience maybe, who in here is using C++ 11 for embedded development? Could you raise a hand? And who's using 98 still? Oh, all right. So we're very conservative then, I guess. On the other hand, if a customer comes to us and we say, no, we can't help you, then it's going to be lost business.
Yeah, well, it depends very much on what your exact business model is in terms of if you're regularly presented with chips that are 10 or 12 years old, then that's going to put you in a very different space from people who might be able to choose who have projects that are 1 to 2 year life cycles, and then they move on to a new, more modern chip.
A short follow-up on that is one of the features that we're reaching for is, since we don't always have dynamic memory, obviously, move semantics would be really good, I think, to be able to move stuff out of factory functions and stuff like that. Is that something that you have? Maybe I'm derailing from someone else here, but is that feature something you have observed to be useful in these situations?
Yes, very much so. I mean, the model that we have been using recently in our contract development stuff is, you have a pool allocator, so it's got chunks, and you have a list of types which you're allowed to allocate. And when you allocate something, you basically have something a little bit like, maybe make shared or make unique, where you say what type, and then you pass it in the parameters for its construction. And so you can't get one of those without it being in a smart pointer. But since we know all the types that it could be, it's also somewhat a variant, right? So you can visit it, even though you don't know what type it really is. And when it goes out of scope, it gets deleted automatically. So it automatically goes back into the right pool, because delete is also a visitor that just figures out what type it is, and it goes back in. And the beauty of this is, since we know all the types that that are dynamically allocatable in our system, right? Then we can do things like add an intrusive linked list pointer, or if we have less than 16 bits worth of slices in all of our pools, which we usually do, we can, it doesn't have to be a full pointer, it can just be 2 bytes. And so it's a fake pointer, a compressed pointer, or whatever you will. And then, making queues becomes very cheap because you have an intrusive pointer, right? So a queue, cost of a queue is basically 2 pointers if you want it to be, weight-free, multi-producer, multi-consumer, or 1 pointer if it's going to be, more stack-like. And all of your dynamic memory can be in any one of these queues, so you have less sort of starvation scenarios. And you have a much, 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 much more robust interface on, dynamically allocated things. Like, you can add a member to a struct, one of these types, which would make it larger than would fit in the pool. That's just probably going to be a bug that somebody's going to find at runtime in one of these awesome tools that these vendors are peddling. Whereas in our model, template metaprogramming just moves it from that pool into that pool because it got bigger.
Thank you.
Next.
Yes, my observation is that we as C++ programmers often, we want to use C++ because it gives us access to a lot of abstractations, such. Many of them more or less require you to enable optimizations in a compiler. And that meets, in my opinion, in my experience, means a lot of resistance from the old C folks, because they tend to handle C as an assembler with slightly nicer syntax. Have you any opinions?
Yeah. I mean, from a C point of view, one-to-one mapping of code to assembler is really important. So at certain stages of development, that's a very, very critical thing, especially if you don't know the chip is stable, right? There are different levels, as I said, when I was explaining the different levels from chip going right down to, we've got a stable thing and everything's wonderful, right? Completely different embedded problems. Here you're dealing much more at the application level. Here you're dealing with absolutely lockstepping to see exactly what's happening, and you switch off all optimization, because optimization, you hide that link, and you want to see exactly what's going on. So the C people go to that level because of just historical dealing with really hard hardware problems, right? So that's really why. Once you get stable, you can do all sorts of clever things, right? If your serial port produces output or whatever, your peripherals all do the right thing, then you can go you can go to the next level. But there's a stage before that where you want to be very careful.
Because I worked in a project where they had copied old C code as the base, because that was used in many, many, many products. And our product had that base, but it also had like fancy boost spirit stuff and such. And we still had to compile the whole shebang with no strict aliasing, because otherwise things would blow up.
Yeah, and also the compilers can be immature. so you've also got the hardware that can be immature, but you can also have the compilers are immature, and they can be immature between different releases in the same. 3 may work fine, 4 may not, right? And in embedded worlds, strange things happen where the feature that you enjoyed suddenly doesn't work in the next version, and then you have to wait for the next version after that. So it's complicated.
Does that problem come from semantics that are valid C but not valid C++? Yes, for like the strict aliasing stuff? Or?
Yeah, the aliasing rules are different in C than in C++, and that can bite you. There aren't really well-defined rules for what volatile is and should be. And so in practice, those are often different between whatever C compiler was used to write that C and whatever C++ compiler you're using now. So yeah, I mean, this can be coming from that difference. It's, in my experience, more often somebody did something which was against the rules, but they didn't get bitten by it because they didn't turn on enough optimization, or their compiler wasn't capable of enough optimization to actually exploit that. And so they get bitten later when they upgrade the compiler, even though it's not a language difference or a bug in the new compiler's optimization, which usually gets blamed. It's the fact that they, they treated a function call as a memory barrier, and it is as long as you don't have any kind of link time optimization going on, or something like this.
Or they use some kind of undefined behavior in a broad sense.
Yeah.
And to emphasize, the memory ordering it can be an issue as well, right? Absolutely, your memory barrier and the fences and all of that. And volatile adds to that confusion about whether you have to add fences after the volatile. Some believe in sort of intertwining the fences inside the volatile, which may or may not be a good idea depending on the situation. So.
I actually have, from like real world experience, an example of this where the ARM CMSys library had enable interrupts as function calls into functions that were defined in a different translation unit, which is super inefficient because then they can't be inlined unless you turn on LTO or whatever. And in CMSys 5, they took those functions and put them into a header because that makes things more efficient. And it was only then that I tracked down a bug where when you turn off interrupts at the special function register level, then it actually could take up to 2 bus cycles for that change in bits to actually get there. So you enter your critical section, and after 2 instruction cycles of being into your critical section, where you've probably already loaded the critical thing, then you get an interrupt, right? And the reason why this didn't bite anybody before was because returning from a function took at least 2 bus cycles. And that function was never inlined because nobody turned on link time optimization and it was in a different translation unit, right? So this is actually an ARM hardware bug in my opinion, but I mean, I guess there are reasons that they modeled it that way. And I guess now they have some kind of, bus sync, whatever thing in there. But yeah, it can be very esoteric and hard to find.
I mean, all architectures expose some bit that shouldn't be exposed, right? So every architecture has to do it, and it does it for different reasons, and some is for just pure performance, right? So every architecture has some oddity, right? And there was delayed execution after a branch, which I found really quite strange, right? So you have a branch, and actually the instructions after the branch get executed because they're already in the pipeline, right? And that was kind of strange, right? Whereas the ARM traditionally flushed the pipeline when it took a branch. You've got oddities. That's why we're in embedded. That's why embedded people are employed, because we have to deal with these nasty sort of difficult problems. So, thank you.
On the topic of best practices for incremental migration, is there room for incremental migration of a build system? What I heard about incremental migration of syntax was assuming you were using a C++ compiler for the whole build.
Well, one point I want to make, just to make sure I'm coming around, is I believe it is still true that if you're going to be using a mixture of C and C++, you can do that as long as main is in C++. You can't have I'm not aware of a tool chain that will support a main compiled in C. It will then allow it somehow or another, the software, to invoke components written in C++, not unless you have some real expertise in the tool chain that knows how to make those calls work. But all the tool chains that I'm familiar with say if main is in C++, then you can use C linkage to get to any of the C code. Is that your understanding?
That makes sense with what I've read, yes.
Okay. So really, if you have a C code base and you want to migrate to C++, and Ben hinted at this earlier, but I don't know that you stated explicitly, is that before you do anything else, before you start trying to use classes, first thing you do is make sure the whole thing compiles with main as C++. And then it may be that separate components are compiled as C, and you have to have then the appropriate interfaces in the C++ part that declare those components with C linkage. And that allows you to do that stuff incrementally. But as far as I know, you still have to be using the same one linker, common linker for all of that stuff. You can't have a mixture of tools to support that build. I haven't seen that. I'm not saying it's impossible, but I've not seen it done anywhere.
Thank you.
Hi. The panel's already mentioned that embedded systems programmers tend to be pretty conservative, and when it comes to the C++ features that we use. One of the areas where it seems like we universally shy away from is exceptions. But it seems, in my experience anyway, that disciplined use of exceptions tends to produce more readable code than error code sprinkled all over the place, especially, or like you're checking for errors and then jumping to a to a label somewhere. I've been hearing a lot about static exceptions, the static exception proposal. I was wondering what the panel's view on that proposal was. Are we actually going to get something we can use on a bare metal system?
And John, can you answer?
Oh, he's putting over there. I mean,
well, it's early days.
give him a mic. Give him a little chair.
On the spot.
Tell people who you are.
Yeah, I'm John. I'm co-chair of Study Group 14, which represents embedded to the Standards Committee. You're probably referring to deterministic exceptions, and yes, that's quite a preliminary stage. It's not something that we're going to see for C++ 20, and one of the main things we have to see is how much resistance we experience from the broader kind of committee, because certain parts of it, Study Group 14 and Library Evolution, are both fairly favourable towards it, and also Working Group 14, who standardise C, are remarkably happy with it and are kind of helping out, in particular with the interoperability with C. However, there are a lot of companies and a lot of other study groups and people with a vested interest, with a stake in C++, who might take a very different view. So it's kind of, I would wait and see. But I wouldn't be, I mean, also it's something that would take maybe a few revisions to really take effect, because there's some things you need to deprecate with a change that big. So it could take, there may be some small progress in maybe C++ 23 and then more and more in subsequent revisions. But yeah, I mean, there's certainly a lot of enthusiasm for it. Yeah.
Thank you.
Don't hold your breath.
Oh. 10 years. Maybe, all right.
10 years.
I can wait, I guess. Thank you.
Yeah, I think it's promising, but yeah, definitely early days, and there are a number of different error handling schemes that are being looked at in modern C++, and I think that there's some resistance to the idea of adding yet another way of handling errors. So that gives you some idea of where the discussion is likely to be focused.
Great, thanks.
You asked what the panel thought about it. I think it's the awesomest thing since sliced bread. It's probably better than sliced bread, but you can actually emulate something somewhat similar with a lot of legwork. With discriminant union, return, and then do arrow domains and translating and blah blah blah.
Like making your own optional or something along those lines?
Yeah, something like boost outcome.
Okay.
I mean, the design of the deterministic exceptions is influenced a lot by boost outcome. And yeah, but I agree, it won't be 20. We may get in 20 the actual type that gets returned in library space, and so you can kind of use that as a you'd still have to write it out explicitly. It won't be compiler magic hiding it,
Right, yeah.
but it will be probably not AVI compatible, but you don't care on embedded systems. You recompile everything anyway.
Yeah.
But you get what I mean.
Yes, yeah. Thanks.
Any more? Okay. Next.
So, what are the other proposals that the group is discussing that impacts a lot on the embedded?
You're asking about what are some of the other proposals that SG14 is considering at the moment?
Yes. What are the language features that we might see in 20 or in the future that impacts this this kind of embedded?
I mean, there's a whole bunch of them. Generally speaking, in the SG14 monthly meetings, we don't have enough time to get to everything that we would like to get to.
What excites you guys most?
So on the subject of exceptions, but not exceptions, I think contracts be very useful in a number of ways. Firstly, very often exceptions are used, I would say incorrectly, where really a contract is being violated and there's a bug there, and you don't want to handle it gracefully. You want to see a crash stack or whatever you can get to try and fix that error. And contracts will provide a certain amount of flexibility for allowing diagnostics to be printed out and for processes to terminate quickly on discovery of an error, which may be a benefit in safety critical domains as well. So that's something that looks like it was in the draft for 20, which I'm personally quite excited about.
Wasn't there also the freestanding, or any C++ functions that they call?
Well, I thought that the question was directed to C++ 20 specifically, and I think that the freestanding proposals, while they are very interesting and they will impact the embedded space quite substantially. I don't think we're looking at them for C++ 20. I can talk a little bit about that if you like, but.
Listen, I'm going to have a question back to the panel, actually. So for embedded, what multi-threaded changes are going to happen in C++ for the embedded world? Because we're now on quad cores as a sort of normal, and so multi-threading is important. Or is there any plans for that side?
Well, I think, my favorite feature for embedded probably coming in 20 is coroutines. Because, even if we program on 4 cores, it's still usually more an event-based paradigm. And it's much, much easier to program in that paradigm if you have coroutines rather than, chaining callbacks or, that kind of stuff. So that's what I'm very excited about.
And evading the issue of multi-threading even more, another good way to avoid problems with multi-threading is to have as little state as possible, and the increasing amount of things that can be put into constant expressions is a very big deal, not just for multi-threading, but for systems where you have maybe not much RAM, but a lot of ROM. Constant expressions soon will be able to include dynamic allocations, which will mean kind of pretty much arbitrarily complex containers and things like that being available right when main starts, and that's a big deal for embedded, I think.
Building on what John said there, I think that the continued development of finding new ways of using constexpr is going to produce some very useful features for embedded space, some tools that will really allow us to do some very impressively efficient things that really beat the pants off of anything else that you would have been able to do beforehand. The other thing that comes to mind, based on what Andrew was saying, was actually that this is a feature from C++ 17, but I don't think it's been very well publicized. The hardware constructive and destructive interference size values. This is a feature that's built into the language that allows you to make statements about the size of the cache mechanism, so that you can construct types that are designed to be either on the same cache line or on different cache lines. And especially as we move into more multi-core systems, I think that that's going to become a very important optimization to take advantage of in embedded systems programming, is to make sure that you don't have collisions where you don't want them, and where you can optimize things into the same cache line as needed.
Any more questions?
Just is it already in 17?
Yeah, hardware constructive interference size and hardware destructive interference size. Those are the. One of them is the size that you're guaranteed, that makes something guaranteed to be in the same cache line, and one of them is the distance apart which things have to be in order to definitely not be on the same cache line. Those things are in 17, and
they're constexpr.
Yes. They are constexpr values, and they are a feature that you could, well, if you have a 17 compatible hardware tool chain, you can make use of them now, as we were saying before. That's something of a big if with embedded development, unfortunately. But I think that will increasingly become a very important thing to take advantage of, because the measurements that I've seen suggest that it can be quite a substantial performance improvement.
Maybe
So I'll ask the audience a question, right? When I introduced myself, I said, the world is constantly changing, right? So for the last 50 years or so, we've been in what I would call an exploitive world, in the fact that we understood the problems that we were tackling, right? If you look at the types of problems that the high-end, the bigger systems are dealing with, they're dealing with sort of machine learning, they're dealing with classification, they're dealing with correlation, they're dealing with a whole load of these sort of weird words. And, at some point, that world starts coming down to the embedded world, right? And so us as embedded engineers, we had to deal with the GPUs, we had to deal with DSPs, we had to deal with processors, but, there's a point when we're going to have to start dealing with the ML accelerators. That's coming down. And so from a language point of view, and especially a C++ point of view, is how to effectively use those new accelerators is going to be sort of the challenges going forward, right? Because at the moment, everyone's going to be producing different accelerators. They're sort of based on some matrix operations with wacky wide multipliers, basically, and the ability to fit those into sort of some software paradigm that fits into more of the machine learning algorithms is going to be something that we will have to adopt and understand as embedded engineers, right? So that's going to be one of our next big challenges, right? So the question is, taking just this audience as just a sort of a sweepstake, how many people are seeing ML being part of their lives today? And it's probably going to be, oh wow, more than I expected actually. You're starting to tackle that now, and and the language will have to start looking at those pieces, like it had to deal with multi-core and GPUs and all of these other things, right? So,
Well, the new thing is the NPUs that are coming out.
Yes.
And they're basically using graphical processing to figure out which node to go to.
Yeah, and then you've got the TPU, which is a Google type thing that, predominantly now, mostly Python actually, rather than C++, or Python is more used as a glue. I mean, the C++ may be hidden in the libraries underneath, but basically Python acts as the glue construct, right? And but as people want faster and faster performance, Python is not the most performant of any language, if anyone's had the experience of using it. So the language may, the C++ definers may actually have to move into that area and try and optimize C++ in that direction as well.
Well, I guess we have no more questions. I thank you all for your time and your questions. If you have any more questions, you'll see our website, our pictures on the website, and if you can, send us an email or just meet us out in the hall. So thank you and have a good night.